an equation here with three unknowns. So it looks like there's going to be an infinite number of solutions, but wait. First of all, we are told that they are all integers, so that is a different ballpark. That makes it a Diophantine equation. And secondly, there's a further restriction. They have to all be positive, and that is actually the crucial thing that's going to allow us to get a single solution to this question. So let's take a look at this second term, in fact, okay? Because n is an integer that's one or more, when I add it to 1 over p, I'm definitely going to get something that is more than 1. And then if I do 3 divided by something that's more than 1, that is going to be less than 3. Okay, that is a crucial thing in this question. So m couldn't, for example, be 1 because then this would be, well, there's no way I'd get 14 here. So in fact, I need to make m as big as possible. It can't be 6 because then I'll get 18. This will be negative. It's got to be 5 because then I get 15. I get something here that will be less than 3. In fact, it's got to equal 2. M equals 5. I didn't, I've explained it verbally. I've not shown all my working, have I? But since require, maybe I will show my working since require. Okay, and that means we can substitute in 15. We're going to get here. So it's going to be 3 over n plus 1 over p is equal to 2. And I can multiply through now. So 3 is going to be 2n plus 2 over p. Now this thing here is, I'm dividing, remember, p is a positive integer. It's got to be less, or it could be equal to 1 or 2 because everything else is an integer. But ultimately, it's got to be less than or equal to 2. Okay, that's the point I'm trying to make here. So n can't be something like 6. That would be, it's got, then this wouldn't be positive. So n can't even be 2. Actually, n has to equal 1. Remember, it's a positive integer, and this thing's positive as well. So n is 1, and then we're going to get that 2 over p is equal to 3 minus 2 is going to be 1. And that gives us our answer we're interested in. P has got to equal 2. So that is the only solution to this equation. We just kind of worked our way through it. There's restrictions on it because they have to be positive integers. P is 2.